Hey, so in today's video, we are going to be looking at relative and absolute extrema, which is really just a fancy word for saying maximum and minimum points. So maybe a loose definition of what I mean between relative and absolute. Relative refers to a point compared to, relative is, or are points compared to local points, things that are near the point of reference there. And then absolute, that would be compared to, that's compared to the entire function, and then we'll also talk about, again, end behavior, which we should be pretty decent at this point in the course. So maybe I'll sketch a graph to show you what I'm kind of talking about. Let's sketch a quick plot right here. We'll just call this function f of x. Okay, got this function f of x. So we've got quite a bit going on in this function. Remember, when I talk about relative and absolute extrema, I'm really just talking about maximum or minimum points, values. So this point right here, you see where we kind of reach this valley? That's the lowest point, the minimum point relative to those points around it. So this point here is a relative, that is a relative minimum value. It is the lowest point compared to those ones around it. And then we start to climb, and then we reach the tip of this peak. So this is the highest point compared to those around it. Again, that is a relative, but this time, since it's a peak, it's the top of a function, this one's going to be called a relative maximum value, relative max. And then we continue with this function. It starts to go down and down and down. Eventually, we reach this valley again, the depth of this valley. So this one, we can see pretty clearly that the function never actually goes below that point. So this is the absolute lowest point of our entire function. So instead of just being a relative minimum value, this one's called an absolute minimum value. And that's really your goal for today, is just look at the graph of a polynomial function and try to figure out, are these relative or absolute? And then are these points maximums or minimums? For this one, it's a relative maximum because, of course, it's the tallest point around those, near it. But you can see pretty clearly from the graph, like right here, this point is higher than this point. That's why it's a relative maximum and not an absolute maximum. All right, so let's look at some graphs on Desmos and try to pick out some of these key features. So let's do this first one. Got negative 7x to the power 4, and then all of this stuff behind it. So again, we're trying to pick out the relative or absolute maximums and minimums. So looking at this function, we start by increasing until we get to this peak right here. So this point, it looks like it's at around -1, maybe 3.5 or so. I can click on it to get the actual location. -0.78, and then the y value is 3.495. So our function never actually goes above this point, which means it's an absolute maximum. This is an absolute maximum value. And then if we just keep following our function, we start to go down, and then eventually we get to the bottom of our value right here. Now, we need to figure out, first off, is this relative or absolute? And just by looking at the graph itself, we can see that, well, these points here are lower than this point. So this is a minimum value, sure, but it's only minimum to those points that are local to or around it. So this is a relative. This is a relative minimum value. We start to increase again. We get to this peak here. So this would be known as a relative maximum. We know it's not an absolute maximum value because this was our absolute maximum value. It never got above this point. Our function never goes above this. However, at this point, is a max value relative to those around it. So just looking at like these two curves right here. And then, like I said, I wanted to review end behavior once more. Should write as x approaches infinity, the function itself approaches negative infinity. As x goes to the right, the function is going down to negative infinity. And then as x goes to the left, as x approaches negative infinity, the function is approaching negative infinity in that direction as well. Just looking at the left side of this function, if we were to follow it, it's going down and it's never going to stop going down. All right, so that'll do it for this first example. Let's graph the other polynomial that I have prepared right here. So this new one, it's in blue. Once again, let's try to pick out the relative and absolute extrema, the maximum or minimum values of this. So hey, for this polynomial, it looks like we are once again just increasing to begin with. We start by increasing and eventually getting to this peak right here. Now, compared to the entire function, it's not the maximum value. We have a maximum value right here, for instance, right? Or not a maximum, but this point is higher than this point. So this would be known as a relative maximum value. It's taller than the points around it, but it's not the tallest point of the function or the highest point. And then we start to decrease. We keep decreasing until eventually we get to this point here. So this one would be known as a relative minimum. This would be a relative minimum value because you can see that, well, hey, this point right here is lower than this point. So it's not an absolute minimum value. This point is just smaller than kind of the points that follow this curve right here. The ones local to it within some interval. It is the relative minimum value. It looks like that's all we've got. We've got the relative max right here, the relative minimum right here. Now we'll just describe the end behavior real quick. So as x approaches positive infinity, the function is approaching positive infinity as well. As we move to the right, the function is increasing that entire time. And then as x approaches negative infinity, the function is approaching negative infinity. What that means, right, is just looking at the left side of the function. If we were to follow it, going to the left, you see that the function is going to be going down and it's never going to stop going down. It's approaching negative infinity. So that's really it. That's what you're going to be doing on your assignment today. Just determining whether these points are relatives or absolutes, and are they max or min values. And then also just remember how to describe the end behavior of a function. All right, y'all, that'll do it. Thanks for watching. See you in class. Bye-bye.